the universe has always been a vast and mysterious place, filled with questions that scientists have spent centuries trying to answer. How did it all begin? What was the universe like in its infancy? What are the secrets of galaxies, stars, and cosmic phenomena that seem to defy all our known laws of physics? For centuries, these questions have remained unanswered, but now, thanks to the advent of the James Webb Space Telescope, JWST, we are finally peering deeper into the cosmos than ever before. The revelations coming from this groundbreaking mission are changing the way we think about the universe and, in many ways, rewriting the very laws of physics that we have built our understanding of the cosmos upon. Imagine this, a telescope so powerful that it can see light from galaxies formed just 300 million years after the Big Bang, a time when the universe was still in its infancy, and yet, we are witnessing galaxies that are far more complex and developed than we could have ever imagined. This is exactly what the James Webb Space Telescope has begun to reveal to us. One of the most astounding discoveries so far is the galaxy known as JWST 13. This galaxy, located over 13 billion light-years away from Earth, is so old that it completely challenges our current understanding of cosmic history. According to traditional models, the universe should have been too chaotic, too hot, and too dense for such large and developed galaxies to form so soon after the Big Bang. And yet, there it is, a perfectly structured galaxy with an astonishing number of ancient stars, an enigma that has scientists questioning everything they thought they knew about the early universe. This is just one example of the kind of discoveries that the James Webb Space Telescope is making. As scientists continue to study the data coming from this advanced observatory, they are finding more and more galaxies that defy explanation. These galaxies, some of which are older and more mature than we ever thought possible at such an early stage of the universe, are forcing astrophysicists to rethink their models of star and galaxy formation. They are providing us with a direct window into the distant past, offering unprecedented insight into the conditions of the early universe. And with each new discovery, scientists are being pushed to confront the possibility that our current understanding of the universe's origins, structure, and evolution may be deeply flawed. The implications of these discoveries are profound. For years, scientists have relied on the Big Bang theory as the cornerstone of our understanding of the universe. According to this theory, the universe began as an incredibly hot and dense point around 13.8 billion years ago, and over time, it expanded and cooled, eventually leading to the formation of stars, galaxies, and everything else we see today. However, the observations made by JWST are challenging this narrative. If galaxies like JWST 13 were already fully formed just 300 million years after the Big Bang, then it raises the question, how could such large, complex structures form so quickly in a universe that was supposed to be too young and chaotic to support them? Were we wrong about the timeline of galaxy formation? Or perhaps, more radically, was the Big Bang itself not the sole origin of the universe? The discovery of JWST 13 and other similar galaxies is not just a curiosity, it is a scientific revolution. These galaxies are not just anomalies, they are evidence that our understanding of the cosmos may need a complete overhaul. The Standard Model of Cosmology, which has been the foundation of astrophysics for decades, is based on the assumption that the universe was initially too hot for stars to form. According to this model, it took hundreds of thousands of years for matter to cool enough to allow the formation of the first atoms, which then led to the formation of the first stars and galaxies. But if galaxies like JWST 13 already existed 300 million years after the Big Bang, it suggests that star formation must have happened much earlier and much more rapidly than previously thought. This discovery is just one piece of the puzzle. In fact, the James Webb Space Telescope has revealed a number of other surprises that are forcing scientists to question many of the assumptions they have held about the universe. For example, the JWST has detected galaxies that are not only older than expected but also far more developed. These galaxies contain an astonishing variety of stars, ranging from young, hot stars to older, cooler stars. This discovery suggests that the early universe was far more complex than we ever thought possible, and that galaxies were capable of forming and evolving in ways that we have yet to fully understand. The discoveries made by the James Webb Space Telescope are so groundbreaking that they are shaking the very foundations of astrophysics and cosmology. The implications of these findings are still being fully understood, but one thing is clear: the universe is far more mysterious and complex than we ever imagined. As scientists continue to analyze the data from JWST, we can expect even more astonishing revelations in the years to come. But the discoveries of JWST are not just challenging our understanding of galaxy formation, they are also forcing us to rethink some of the most fundamental questions about the universe itself. One of the most intriguing possibilities raised by these findings is the idea that the universe could have originated from a black hole, rather than from a singularity as proposed by the Big Bang theory. This idea, which was once considered purely speculative, is gaining more attention among scientists as they examine the evidence presented by JWST. The concept of a universe born from a black hole is not new. In fact, it was first proposed by the renowned astrophysicist Roger Penrose, who introduced the idea of a cyclical universe, a universe that is born, evolves, and eventually dies, only to be reborn again in a never-ending cycle. According to Penrose's theory, the end of one universe could lead to the creation of a new universe, with black holes acting as the gateway between them. This theory suggests that the Big Bang was not a one-time event, but rather a natural consequence of a black hole reaching the end of its life cycle. If this theory is correct, it could mean that our universe is just one of many, with each new universe emerging from the remnants of an old one. Recent findings from the James Webb Space Telescope seem to support this idea. In addition to revealing ancient galaxies that shouldn't exist according to our current models, JWST has also found evidence of ultramassive black holes existing in the early universe, black holes that are far larger and more developed than we ever expected. These black holes could very well be the remnants of a previous universe, providing further evidence for the idea of a cyclical universe. If these findings are correct, it would mean that the universe is not a one-time event, but rather a never-ending cycle of birth, death, and rebirth. The implications of this are mind-boggling. It would mean that the universe has no true beginning or end, and that our understanding of time itself would need to be completely redefined. But the revelations of JWST don't stop there. The telescope has also provided us with new insights into the formation of the first stars. For decades, scientists have theorized that the first stars, known as population 3 stars, were massive, hot, and short-lived. These stars were thought to have been the first objects to form in the early universe, and their explosive deaths would have seeded the cosmos with the heavy elements necessary for the formation of planets and life. However, the James Webb Space Telescope has not yet detected any evidence of population 3 stars. Instead, the galaxies it has observed contain a mix of stars from different generations, suggesting that star formation in the early universe was far more complex and varied than we had previously thought. This raises the possibility that the first stars may not have been as simple or as uniform as we imagined. Instead of a single generation of massive, short-lived stars, there may have been multiple generations of stars forming in different ways and at different times. This could mean that the process of star formation in the early universe was far more dynamic and diverse than we ever thought. And if this is the case, it could have profound implications for our understanding of how galaxies and stars evolve over time. The discoveries made by the James Webb Space Telescope are nothing short of revolutionary. They are forcing scientists to confront the possibility that our current models of the universe are incomplete, and that the true nature of the cosmos is far more mysterious and complex than we could have ever imagined. These findings are not just important for astrophysicists, they have the potential to change the way we think about the universe and our place in it. As scientists continue to analyze the data from JWST, we can expect even more surprises in the years to come. The universe, it seems, is still full of secrets waiting to be discovered. And with the James Webb Space Telescope leading the way, we are finally beginning to uncover some of those secrets. In the coming years, the James Webb Space Telescope will continue to provide us with a wealth of new data, and with it, the promise of more groundbreaking discoveries. As we gain a deeper understanding of the universe's origins, its structure, and its evolution, we will undoubtedly encounter even more challenges to our existing models of cosmology. But one thing is certain, the discoveries of JWST are a glimpse into a future where our understanding of the cosmos is not just expanded, but completely transformed. The universe is far more mysterious than we ever imagined, and with each new discovery, we are getting closer to unraveling its deepest secrets. The journey has only just begun.